Today we are going to go over how to graph hyperbolas. We are going to first learn the different parts of the hyperbolas in order to be able to do this. So let us go ahead and start here with this first paragraph. A hyperbola is the set of all points x and y such that the difference of the distances between x and y and two fixed points called the foci is constant. Foci just means plural for focus. So in this case, we're going to have two focus points. The line through the foci intersects the hyperbola at 2 points. These points are called the vertices. Plural for vertex. The line segment whose endpoints are the vertices is called the transverse axis. The transverse axis is very similar in importance as the major axis was for the ellipse conic. And the midpoint is called the center of the hyperbola. So again, here we're dealing with center, just like we did with ellipse. So let's take a look at the diagrams here below. One of a horizontal hyperbola and one of a vertical hyperbola. And let's include some labeling to help you understand the different important characteristics that you will need to include when you're graphing. So let's start here with the center. So the center is right dab in the middle. So we don't have, do I have a point here somewhere where I can draw the center? I think I didn't put a line, but right here, I'll put it in, I guess we already have the orange, but there is the center right there. Okay, now to the right and left of the center in blue dots, you are going to see that are the points called the vertex, okay, the vertex points or the vertices, okay? They're to the right and left of the center when it's horizontal, but if you look over here, the center is right here. It will be above and below because it's a vertical hyperbola, okay? Now, the next that we're gonna get is the focus points. And we call them foci because there's more than one, okay? So I'm going to put foci here just to draw attention to the fact that we know that there's two. So there's one right here and right here. There's a pair. And what I want you to notice is that, I'm going to circle again, all these 5 points, the circle, the two vertices, and the two focus points make up 5 points. And these will always sit on the transverse axis. So I'm going to write transverse here. Okay. I want you to always remember the transverse axis will always have 5 points. If we look at the vertical hyperbola, count with me. There's 1, 2, 3. And on this diagram, please include this point here and this point right here because I did neglect to include the foci. So 1, 2, 3, 4, 5. Those are 5 points that are vertical because they sit on the vertical transverse axis. The transverse axis is always going to be perpendicular to the conjugate axis. And this is right here. The conjugate axis is tantamount to the minor axis that we discussed in ellipses. We also have what we call co-vertices. Co-vertices are minor vertices, basically. Okay, co-vertices. So I'll call it co-vertex here. Let's do this. Let's call it co-vertex, but there's 2 of them, okay? There's this one and this one. And last but not least, we have the asymptotes. The asymptotes will always be depicted by 2 dashed lines, and these help determine the width of our parabolas, okay? Our pair of parabolas, our hyperbola. So let's actually look at what those standard equations look like. So here is the equation of a hyperbola when it is in horizontal form, and this is the equation when it is in vertical form. Now, the first thing I want to point out to you is the fact that notice that the two rationals are being subtracted, whereas in ellipses, we had a plus sign, okay? So that's the major difference in our formulas. What I want you to notice, though, is the following. The first thing that I would task you guys to do in ellipses was find a squared, right? And a squared was bigger than b squared when we worked with ellipses, okay? So notice that I am purposely going to put this in a circle because I want you to understand that this had to do with ellipses, okay? This is not the case. This is not the case with hyperbolas, okay? This is not the case with hyperbolas. A squared will always be found underneath the first denominator value. Notice a squared was in the first term and a squared was in the first term, no matter if it was horizontal or vertical transverse axis, okay? So a squared, when you're going to find it, please make sure you always choose the first denominator value. So for hyperbolas, a squared will always be the first denominator value. Does not matter if a squared is bigger than b squared, or if b squared is bigger than a squared, or even if they're equal to each other. We do not care about that on hyperbolas. You will notice still, though, wherever your a squared is, you will still look upstairs, and since a squared is under the x in this specific instance, it's going to be horizontal. Here the a squared was under the y term, so it's going to be vertical. So orientation of our transverse axis, which we would call major axis for ellipses, those still remain the same on determining that, okay? I want you also to notice that foci, the definition of foci is going to change for hyperbolas, okay? Notice we add when it is in hyperbolas. For ellipses, I'll put this over here like this to make sure you guys understand that this was ellipses. We use the formula c equals plus minus the square root of a squared minus b squared, okay? But here, we will be adding for hyperbolas, okay? So note the difference. Let's go ahead and practice some graphing. So here's our problem. X minus 4 squared minus y minus 2 all squared over 9 equals 1. So finding a squared is the first thing we want to do. And remember, a squared is always the first denominator value. So if you look at this right here is my denominator, right here. It's invisible. So that is understood to be a number 1, okay? So I will rewrite it like this, over 1. So we know that a squared equals 1. So if I square root a squared equals 1 on both sides, I'm going to get a to b plus and minus 1. Therefore, b squared has to be the other denominator value, in this case 9, square root 9, and I'm going to get plus minus 3. Let's find c. We recall that c has a new formula when it comes to hyperbolas, and we add a squared plus b squared. Well, a squared was the first denominator, b squared is the second denominator, and we get plus minus square root of 10. Square root of 10 is approximately plus minus 3.2. So I'm going to come upstairs in my little graphic organizer here and put plus minus square root of 10. The center, we do the same thing we did with ellipses. Take the opposite value of what is inside those two parentheses. Make sure we put it in order of x comma y. Well, the x is going to be a 4, and the y is going to be a positive 2. Okay, so let's go plot that. Let's go to put the center at 4 comma 2. So 1, 2, 3, 4 to the right, and up 2 will be right here. That's our center. Oops, I did not mean to do that. Hold on, technology issues here. Wow, I erased everything. 4, 2. Okay. Now, the vertices, let's remember this. The vertices and the foci and the center. Remember, those made up our 5 points. Center is 1, vertices 2, foci 2. All those were 5 points, and they sit on the transverse axis. Now, the orientation of the transverse axis was dependent on our a squared. Our a squared was right here. We look upstairs, and we notice it's an x. So our transverse axis is going to be horizontal. All right? This is our transverse axis. So the center, the vertices, and the foci all have to be on a horizontal transverse axis. So if I'm already at my center and I need to go to my vertices are dependent on my a distance. So a distance was plus minus 1. So I'm going to use blue to determine my vertices. I'm going to use blue. So I'm going to go plus and minus 1 right there. Then for my foci, I had to go, what was that? Plus and minus 3.2. Okay, I'm going to use green here. So I'm going to go, 1, 2, 3.2. And then 1, 2, 3.2. So there's my foci. Okay, and don't forget, your foci is dependent on the c value. Covertices, those are dependent on our b value. Okay, they depend on the b. So let's go use that now. So b said to go up and down 3 from the center, so the red dot, 1, 2, 3, and 1, 2, 3. Okay, so we have all these points. Now, typically what we did with ellipses is that we kind of just went like this and said, oh, let's connect those dots, right? But we're not doing ellipses. What we're going to do instead with a highlighter, and you don't have to do this on your paper, but I'm going to do this to make it pop out so you guys can see why I'm doing it, okay? I'm going to take my pair of vertices and covertices, and I'm going to wrap them around with a rectangular box, because I want you to notice how these coordinates of the corners of these boxes are going to help us draw our asymptotes, okay? So our asymptotes are going to be drawn by taking one corner and connecting it to the other corner. So I'm going to take this corner and I'm going to draw a line to the other corner. And I'm not going to be able to do arrows with this little feature. Whoops. It's going to be harder than I thought. Let's see if I try this again. You're going to draw... it's not letting me. There we go. Let me extend it on this side a little bit. Okay. So these are supposed to be dashed lines, okay? And when you draw them, these asymptotes are not part of your graph or anything like that, okay? But they are supposed to help us, not supposed to, they will help us with the drawing of how wide our graph is going to be. Now, again, I cannot seem to get this pen to cooperate, but you guys get the idea, right? There we go. Bear with me on that one. Well, I can't bear with it myself. Let's try that one more time. The pixels are too close. So anyway, if you would think that I can extend it, but I can't. It's really weird. See what it's doing? Okay, so pretend that's really straight. Well, there you go. It's sort of straight. So let's do this. So what you're going to do, since you know it's going to be horizontal, that means the graph is going to point to the left and to the right. And you remember, our vertices were the blue dots, okay? So right here and right here is where our graph is going to start. So what you're going to do is, from that curve, from that blue dot, you're going to curve your graph close enough to that box and go close enough to the asymptotes, but do not touch it. And you're going to go over here and you're going to do the same thing. And then you're going to come over here on this side, go to your vertex, curve, curve, curve toward the asymptotes, don't touch, and do the same thing on the other side. Okay, whoops, that doesn't look that great. Let's try that again. Notice how close I get to the box and to the asymptote. So those peach colored curves are our graphs of our hyperbolas. And we can go ahead and put all the coordinates of our vertices and our co-vertices and whatnot. Well, our vertices, we went to the right 3 and up 2 for the first blue dot. The second blue dot, we went 5 over and up 2. Now the co-vertices were the grayish dots. We count 1, 2, 3, 4. 1, 2, 3, 4, 5. 4 right and 5 up. And then we know it's going to be 4, but this time we went down 1. Now, our foci, we went to the left and right square root of 10 from the center. So again, since we went left and right, you will start at the 4 and say I went left and right square root of 10. And the y value still stayed at a 2. Okay? So, let's try this again with example number 2. Let us start again with finding our a squared value. A squared value is right here. It is underneath the y. So we know that a squared equals 4. So our a has to be plus minus 2. Since it's under the y variable, this time we are going to be drawing a vertical hyperbola. Up, down. The b is the other number. B squared is the other denominator, which is 4. And therefore, this 2 is plus minus 2. Okay? And the c, we calculate it by taking the square root of the sum of the 4 and the other 4. And we're going to get plus minus the square root of 8, which when you rewrite it, it's going to become 2 square root of 2. But we need to simplify 2 square root of 2 into a decimal format for future graphing. And that gives us a 2.8. Okay? Alrighty. So let's go plot our center. Let's make our center bright red again. Okay? So our center is x comma y. Our x in our numerator was a, right here, had no number, so we're going to put that as a 0. And the y is going to be a negative 1. So you need to make sure and watch your order, okay? Watch your coordinates, okay? Because you may have been tempted to say negative 1 comma 0 because you were reading from left to right, okay? But that's not correct, okay? Make sure you do x first, then y. And notice your x right here is mentioned first. So that's why you put 0 first, and then the y mentioned second. Okay, so let's go put that 0, negative 1 right there. And from 0, -1, we're going to do all our counting. So let's start off with, let's kind of do orange here. So let's make our vertices be orange. All right. Now remember, our center, our vertices, and our foci do all the same thing. The center is going to do vertical movement. Let's see, center was red. Let me color coordinate here. Center was red. It has to be vertical. Vertices is also going to be on the transverse axis, so it also is going to be vertical. How many times is it going to be vertical? Well, we had to go up and down 2. So I'm going to go up 2. I'm going to go down 2. Okay, those are the vertices. The co-vertices always do the opposite. The co-vertices here are going to do the opposite, horizontal. And that was plus -2 from the center. So here's my -2. Oof, that kind of fell off. There's my -2, and here's my +2. And last but not least, our foci are going to do plus minus 2 square root of 2, which I did forget to write here, so let me just write that in. Plus minus 2 square root of 2. All right, so the foci, which we'll use green in this case, also do what's done on the transverse axis. So what am I going to do? I'm going to go to the right 2.8 and to the left 2.8. Vertical. To the go up 2.8 from the center, from red, so 2.8, and down 2.8. 2.8. So notice you have 5 dots on the vertical. Okay, I'm going to circle here, but then I'll erase it. See? 5 dots that are going vertical on the transverse axis. So let us get ready to put in all our vertices. I'm going to have you pause the video, go ahead and put in all those vertices, and then we can check to see if your coordinates are correct. Okay, so go ahead and check your vertices and your co-vertices. And while you're checking, I'm going to go ahead and do my little box that boxes in my vertices and co-vertices. Okay, so that's just like a highlighter that's going on there. And I use this just to be able to determine my corners, okay, to help them pop out. Let's see if my tool here would work a little bit better. There we go, it's actually working. Again, that line would be a dashed line, okay? I don't know if I can make it, let me see if I have time to make it dashed here. It should be dashed, okay? So just for your knowledge, that should be dashed. Now, these are asymptotes. They go on forever in both directions. Let's see if I'm lucky enough to get a good line here on this one. And it works. See, this one's more of a square, so it cooperated so much more easily for me. So again, this is going to be a dashed line. And again, let's put some arrows there at the ends. So these asymptotes help us determine how wide our graph is going to be, okay? So let's go draw our graph. Let us make our graph a green this time. So where are our vertices? Well, they are the orange ones. So let's start with the bottom vertice of 0, -3. I'm going to go against the box, and I'm going to curve towards the asymptote. I'm going to try and make that smoother. Curve towards the asymptote. And I'm going to do the same thing on the other side. And then I'm going to do the one upstairs. Start from my vertice, which is the orange, curve towards the asymptote, and curve towards the asymptote. So there are my 2 parabolas. And my foci are trapped. Right, there's the foci, and right here. They're both trapped inside the parabola, which is exactly what I wanted. Since the foci were found by going vertical, that means I need to make sure that when I write out my foci using the C value, vertical says that I have to put the plus minus with the -1. So that is the coordinates, or are the coordinates for my foci. Let's proceed for the next problem, which is our last one. So what I want you to do is pause the video at this point, and let's have you fill out at least A, B, C, and the center, and then unpause the video, okay? So pause now. Okay, so hopefully here's the answers. Here are the answers that you got. Running this through really quickly. Again, first denominator value has to be your a squared. So we square rooted that and got a 2. Therefore, square rooting 36 gave us a 6 for our b. We added them and then square rooted them to get 2 square root of 10, which is the simplified radical to square root of 40. And the approximation is 6.3. Orientation. So the 4 is underneath the y squared. So we are going to draw a vertical hyperbola. So our transverse axis is going to be up and down. This is the one that's going to have all 5 points. Okay, so let's get to working. So let's go plot that center. I think the center has worked out well, being a bright red. So I'm going to put a big red dot here to remind us that, nope, center is not at the origin, it's at -1, 0. So there's our center, and that's our point of reference. Let us use yellow this time for vertices. So yellow, yellow for our vertices. So we know that, again, the transverse has the center. So I'm going to put my big red dot here. This transverse is going to have my vertices. I'm going to put the yellow dot here again. And so I need to go vertically on a value of 2 to find the vertices location. So from my center, let's go vertical. Up 2 and down 2. 1, 2, up, and down 2 from the center. So those are my vertices. Covertices, you do the opposite, okay? We're going to use brown for covertices. So covertices, you're going to go, instead of up and down, we're going to go left and right 6. 1, 2, 3, 4, 5, 6. Wow, this is wide. 1, 2, 3, 4, 5, whoops. 1, 2, 3, 4, 5, 6. Okay, so there are vertices and covertices. Let's put the coordinates for all of those before we go any further. So for our vertices, we went down 1, no, to the left 1, down 2. So -1 and -2. And the other one was -1, +2. Those are my yellow. For my brown, I went from the origin. I had to go, what is that? 1, 2, 3, 4, 5, 6, 7. So -7, 0. And 1, 2, 3, 4, 5. That would be 5, 0 on the other end. Okay, so if I connected those again, okay, ta-da, connected those, so I can visualize where these asymptotes are going to be drawn. But let's go ahead and see about our foci. Our foci are going to be, let's make them blue. So dot, dot, dot. Okay, so again, look at the transverse, what I'm showing up here. I'm going to scribble here to get your attention. Up here on the upper right, those make up 5 dots. 1 red, 2 yellow, 2 blue. Okay, so always remember, transverse has to have 5 dots. So our foci, we're making it blue. We had to go to the right, 6.3. 1, 2, 3, 4, 5, 6.3. That'll be right there. And to the left, 6.3. 1, 2, 3, 4, 5, 6.3. So a little bit off our graph. Alrighty. So now, what do we do from here? So we need to draw our asymptotes. So if we draw our asymptotes, it has to go from one corner to the next. So let's see if I can be as lucky as I was last time. So here's this one. We'll do some erasing here a little bit. So I'm going to do this here. And then I'm going to do the other one again. And that's not going to work. Let's start from this corner and see if I can do it better. All right. I'll try it one more time. There we go. That's working. And let's go ahead and erase through those. Okay. And we can put some little endpoints of arrows just to make it a point that we are drawing asymptotes. All right, so what are we gonna do now? Well, we have to draw our curves. Now our curves had to be vertical from our vertices. Our vertices are at the yellow. So I'm gonna go to my yellow vertex and I'm gonna curve here. Let's see if I can do this pretty enough. This is gonna be very large and it's gonna be very wide, as you can see. It's a very, very wide parabola. It's almost too wide. And then on this side, we're gonna go from the yellow on the bottom and just curve out and curve out. Okay. Our foci have to be trapped inside of that. So let's do our foci in, what color did we want to use? Whoa, I did my foci wrong, didn't I? Look at that. Let me erase this here. Foci is wrong because our foci have to be inside. So hopefully you caught that. You couldn't scream back at my video. We had to go up and down 6.3. So from here, we had to go up 1, 2, 3, 4, 5, 6.3. And 1, 2, 3, 4, 5, 6.3. So those seem really, really out there. Did I do this right? Let's see. Yeah, I guess this just turns out to be very, very wide. Alrighty. So, yep, let us write out those foci. So since we had to go up and down, it's going to affect our y-axis. So plus and minus with the 0, and 2 square root of 10 went there. And there is our answer, folks. A very, very, very wide hyperbola, my bad. And our foci really are trapped inside those two curves. Hope this helps. Thanks for watching.